So this is, like it says, it is a review of the laws of exponents. You have to, these are things that you've learned in Algebra 1. You should have used some in geometry, definitely used it again in Algebra 2. And be able to apply these properties appropriately. So we have product of powers. So if you're going to multiply two numbers with the same bases, you do what with the exponents? Add them, okay? Power to a power, that's when they get multiplied, right? And power of a product. So if I have two things multiplied together, taken to a power, then it splits up and it gets applied to both. That does not, the same does not apply when this is addition. Okay, so keep that in mind. It does not apply. If this was A plus B, you don't just get to take M and put it on both of those. Does that make sense? So maybe we write that up. A plus B to the M power does not equal A to the M plus B to the M. Okay, that's a very common mistake. So those things are not equal. Okay. All right, quotient of power. So if I have two numbers with the same base, then I subtract the exponents, because when you multiply, you add. When you divide, you subtract. And then power of a quotient, same thing. It gets applied when it's division. Okay. And then 0 exponent, any number raised to the 0 power is equal to 1. And then the negative exponent is the reciprocal. Okay. So all these things are going to come into play when we're looking at solving exponentials with a common base. So this is just there for your reference, since it is a review. And let's look then at solving these. And I already forgot the page 77. Okay, so the little exponents go on 76. This goes on 77. All right, so solving exponential equations using the common base. We're also going to have to do it using logs, but right now we're looking at common bases. So we rewrite the equation using a common base if we don't already have one. Use the properties of exponents to simplify each side of the equation. And then use what's called the one-to-one property. So what that says is if b to the x equals b to the y, then x has to equal y. And hopefully that makes sense. That's a property that you learned in Algebra 2. I'm not going to show you how to get there. Just know that the whole point of this here is that you have to have a single exponential equal to a single exponential. So I'll show you when we get to one of them where there's a common mistake that happens, what not to do, because it's not okay to do it, obviously. All right, so let's start with number 1. 3 to the 2x minus 9 equals 3 to the 7th, right? So these two have a common base, right? And then here are my exponents. So since I have a single exponential on either side, the base is the same, I use the one-to-one property. 2x minus 9 equals 7. Okay, it comes out of the exponents. And so now 2x equals 16x. Everybody okay with that? All right, so let's jump to number 4. Number 4, we have a common basis, so that's good, but we don't have a single one on each side. You do not get to pull them out of the exponents at this point. You cannot do that until you have a single base on either side. So, okay, those variables look like little blobs on my board. Is that a k? Okay. So I've got 8 to the k squared plus k. Is that what that says? Thank you. I can't read it on my piece of paper either. Maybe I need to draw it here. K squared plus k, yeah. Then 2k minus 9. So when I'm multiplying these two, what do you do with the exponents? Add them. So this is 8 to the k squared, and then this is k and 2k, so it'll be plus 3k minus 9. I added those two together. Equals 8, and then these are being multiplied to the 4k plus 11. Does that make sense to you? I am not multiplying the 8s. I am multiplying two numbers that have a common base, and I'm adding the exponents. Okay, we all good on that? So now I have a single exponential on either side, and then I can exponents out. So what kind of equation do I have? called? Quadratic. So I need to do what? Set it equal to 0. So this is my k squared over here. I'll move everything over to the left. So k squared minus k minus 20 equals 0. What's my go-to way to try and solve a quadratic? Factoring. Yeah, it's going to be the easiest thing to do is to factor. And so when I factor this, get k minus something and k plus something. K minus what? 5 and plus 4. So that means that k is equal to negative 4 and 5. It's a little set of numbers because there's more than one there. Okay? Any questions at all? We good at this point? Okay. Now, although if I had taken these out of the exponents and kind of skipped this step and just wrote down this part equals this part, that would be totally illegal because the one-to-one problem is you have to have a single exponential on either side, and that's one of those common mistakes. Yes, you're going to get the same thing, like you know you're going to just add them when you pull them out, but you've got to have that single base before you move on. Okay? Everybody okay with that? All right, so let's jump to number 6. So now I don't have a common base, so I need to come up with one. I also have one that is a fraction and one that is not. So I need them to match. So in order for them to match, one of these is going to have what kind of exponent on it? Negative. Okay, so that 1 over 64, if I make that 64, that'll be to the negative 1 power. So I'll just think of it as 64. But then I'm going to need the base. Can I use 4 as a common base? Okay, 4 to the what power gives me 64? So 4 times 4 is 16 times 4 is 64. So it's 4 to the third. It's 64, but I need it out of the denominator, so it's going to have to be 4 to the negative third equals 4 to the a squared minus 4 power. Right? So I've got a common base. Now I can use the one-to-one property, and I can take them out of the exponent, and I get negative 3 equals a squared minus 4. That is that's a quadratic again, sorry. So I can set it equal to 0. I'm going to add 3 to both sides, so I get 0 equals a squared what? Minus 1. Can you factor that? What's this called? Difference of squares. A plus 1, a minus 1. So now that I have that, I know that a is equal to plus or minus 1. Any questions at this point? All right. So number 8, I don't have a common base, but at least they all have 12 involved in them, right? So to get this out of the denominator, I'm going to have what kind of exponent? Negative. So this is going to be 12 to the negative, and in parentheses, 4x plus times 12 to the x squared power equals 12 to the 2x plus 13 power. So now, can I take that out of the exponents right now? No, because I don't have a single base, a single one on either side. So over here, I need to still combine those, so the base will be 12. And I'm going to add these exponents. So as I do that, I'll just go ahead and distribute that as well. So x squared would come first, be minus 4x minus 3 equals 12 to the 2x plus 13 power. Okay, everybody? So then I'm going to, can I take them out of the exponents now? Yes, so now I have x squared minus 4x minus 3 equals 2x plus 13. I have a quadratic again, so I'll set it equal to 0. I'm going to get x squared minus 6x minus 16. And then can I factor that? Yes, I can, so go ahead and factor that. It'll be x minus what? 8 and x plus 2. Good. So that means that x is going to equal negative 2 and 8. Okay. Any questions? All right. Flip it over. Let's do another one. I'm going to do a few more because a couple other little things come up. All right, let's look at number 10. So on number 10, they do not have a common base. Can I use 8 as my common base? 8 times 8 is 60. 4 times 8 is going to be 28. So that just tells you right there, I'm not going to be able to do that. So since we can't use 8, right? Just 2 times 2 is 4 times 2 is 8. So that would be 2 to the third. So that means it's 2 to the third power, but then that has to be multiplied by this v, which was already there. And then, so that 2 to the third power is 8. And then another would be 16, and then 32, and then 64, and then 128. So it'd be 7. So equal 2 to the times v plus 3 power. So now I have a single exponential on both sides that are the same. I okay that things aren't yet. I can take it out of the exponent now. I can do it as I do that. So this is going to give me 6 minus 3v equals 7v plus 21. And now I just solve this. What do I get? What's going to be? Okay, so what we end up with is negative 15 over 10 if you need to write that. Then you would divide both of these by what? 5. So 15 divided by 5 is 3, and this is 2. So your v is actually negative 3 halves. Yeah, there's only one thing in the set, but it's still, you don't necessarily have. You have to if it's more than one, whether you do or not. When it's just one, it doesn't matter. It's fine. All right, so on number 12, take them out of the denominator. No, I can, but I don't have to, right? If I do, then I'm just more negative. Or I might need to make what power we get 64? Third, because 4 times 4 is 16 times 4 is 64. So just rewrite this one. It's in parentheses. 2x squared. Equals 1/4. Now that to get that to 64, then that's times 2x squared. So if I have 4, then I'd have to take the cube root of that to get it to 1/4. Does that make sense to you? No, yeah. So if I use 1/64 as the base, right? What would make this into 1/4? I'd have to take the cube root of it, right? So Oh, I see what you're saying. Maybe. No, I get what you're saying, but the problem is, in order for these things to... No, okay, I understand what you're saying. So you wouldn't be, but you wouldn't be changing, you would be changing the value of it. Because basically, I didn't change the value of this, right? 1/4 to the third power is 1/64. Do you agree with that? Okay. So if you make this 1/4 to the third power, you're changing the value of it. You're changing it to 1/64. Where this is just changing the way that it looks. Because 1/4 to the third, does that make sense to you? Okay, because basically I'd have to, this right here is still exactly the same, because if I cube this, I get 1/64. If you cube this here, you're cubing it, which means you'd have to cube both sides, which then this still wouldn't be 1/64. Does that make sense to you? Okay, so I get what you're saying, right? That's why you could work like a 1/3 of that. You want that. That's where we are. Okay. Any questions about that? So you always want to use, okay, so this is thing. I see how that can be confusing. So the bases that you use either needs to be the bases that they gave you, like if they're the same, or if you're going to change whatever the base is, it should be less so that you can put an exponent there, not more. Does that help? It's a good question. I get that. All right, so is everybody okay with what I did then? Okay. So then now at this point, I take them out of the exponent. Now 2x squared minus 6 equals 15. And when you do these things, do not forget to distribute to everything, right? That 3 has to get distributed to both of them. So then it's a quadratic again, so I'll set it equal to 0. This will get me, if I move everything to the right, I'll get 4x squared minus what? 9. Can I factor this? Yes. What is this? Yes. Good. It's a difference of squares. So 2x plus 3, 2x minus 3. So x equals, and this one would have to be in set notation because you have more than one. It would be plus or minus what? 3 halves. Okay, everybody okay with that? Any questions about it? All right, let's look at 14. So I do not have a common base, right? I need to get one. What could my common base be here? Okay, 5 totally works. But what did you say? 25, right? Because, you know, I said you need to know your perfect squares up to 25. You need to. And for reason, this is one of the many, many reasons right here. It's because, yes, 5 will work, but your numbers are going to be bigger and uglier. And if you can recognize that you can use 25, this makes this a whole lot easier, okay? Because what's 25 squared? 625. That's something that you need to know. So this is 25 to the a power. So I'm just going to rewrite that. That's 25 to the a power. Times, well, 625 is 25 squared, and then that's to a plus 3 power. And then that 1/25 would be 25 to the what? -1 power. So now I have all the same bases. Can I take them out of the exponents now? No. Got to go one more step. Equals 25 to the -1 power. Now, the exponent on the left isn't reduced or isn't combined all the way, but that's okay. It doesn't matter. I have a common base, 1 on either side. Now I can take it out of the exponent. So when I take that out, that becomes 3a plus 6 equals -1. Right? And then that means that 3a equals what? -7. Good. And then a equals a -7/3. Okay. Any questions at all? All right, so let's do 16. All right, so can I use 8 as my base? Could I use 2 as my base? I don't know. Okay. For these two, would 8 work? Or 1/8, either way. I mean, we can leave it as a fraction. What about 2? Would 2 work? Which one would be easier? 8, right? 64 is not an option. You got to go with the smallest. All right, so I'm either going to have 8 or 2 because the 8 may not work with 512, right? But 8 times 8 is 64. And then what's 64 times 8? It's 512. 64 times 8 is 512. So you can use 8 as your base. Would it be easier than 2? Because your numbers wouldn't be as big or as bad. So yes. So we can either use 8 or 1/8. What would you rather use? What would you most likely use? 8? Okay, because you just kind of don't like the fractions. You want to get, that's fine. Just know that when you do that, you're introducing negative numbers, and that's okay. Just got to make sure you're doing it right. So this is 512 to the y squared power. All right, so that means that we'll get 8 to the 3y squared, right? So that's equal to, well, 8 squared is 64, but I need to get it out of the denominator, so it'd be 8 to the negative 2 power, right? 8 to the negative 2 times 3y power times 8 to the what? Negative 5y squared power. All right, so at this point, parentheses, is that what you mean? Where? Well, I'm not sure I understand the question. Yeah, no, because we're multiplying. If it was more than one term, I would have to distribute, but it's not really distribution there. Does that make sense? You can, like, it just doesn't do anything if you have it there, because this is a negative 2 times a 3y. If that was negative 2, like, back up here, just like right here where I had the parentheses, if that was a negative, or like a negative 2 or just negative, I would need the parentheses because there's addition or subtraction there. But when it's all one term, you don't have to. Okay, that's a good question. All right, can I take everything out of the exponents now? No. So on the left, I'm left with 8 to the 3y squared power equals 8. Okay, so this negative 2 times 3y is negative 6y plus negative 5y squared, which I could have just done as minus 5y squared, but it probably should have. But since I said plus and already wrote it, I'm not going to erase it, but it's the same thing. So whatever, we can just rewrite it the next one. So now can I take it out of the exponents? Yes. So this will give me 3y squared equals negative 6y minus 5y squared, right? So I have a quadratic. Set it equal to 0. Would you agree that moving everything to the left probably would be the best? So I'm adding both sides, which means I get 8y squared 6y equals factor. That leaves me with 4y plus 3 equals 0. So how many? 2. I have 2 factors equal to me. 0 negative 3/4. So I got negative 3/4 and 0. That is my answer there. Everybody good? It's left out in situations like that, so don't forget about him. Questions? All right,